just mindful that Anna Stec has to get on a train at a certain time. And so I'm just going to quickly welcome everybody to the meeting tonight. Thank you very much for coming out on a Friday evening. It's a difficult time for the community. We know we had a flash mob last week exactly about these issues. There are lots of concerns, and in particular our concerns relate to the level of reassurances and how serious we've been taken as a community, because we all know from the meeting in October last year when the interim report, when Professor Stec's interim report was released or leaked, we were told the solution is to wash our hands and wash our vegetables. And I think following your full report, a lot of us feel that actually there is a lot more to be concerned about than just washing your hands and washing your vegetables. So the way the meeting is going to go tonight is I'm going to chair. Everybody knows me, Moira Samuels, local resident, member of Justice of Grenfell. The professor's going to speak after Noor says a welcome and short speech, and then the professor will speak for half an hour, and then we'll have questions. What I'll do is I'll take the questions in 3, and then Anna Stec can come back to those 3, and then people can come back again for another 3. We have you here till 8. Okay, so if while Professor Stec is speaking, people can be thinking about questions. It doesn't have to be directly related to what she says. It may be things that you yourself are concerned about anyway. No question is silly, so please feel free to ask any question. Thank you. No.
Good evening, everybody. I think most of you know me. My name is Nabil Choucair, and today I'm from the Grenfell Trust, and we give you a little bit of context about this meeting. This meeting came out of a need to get some clear evidence about what's happening, especially after the report of Anna, which she's going to talk about. But what I want to say is thank you very much for being here. We took a decision to make sure that only a representative or only few people come to the meeting, so that those people who are here will go and report to others who are not present. And because that's how we feel we should get the information. The information that's going to be given here is on record, so people can use it also, and will be available if you have any further questions, either by email or further down the line, which I'm asking of you.
Yeah, but I'm also will be 25th and 27th coming for the sessions.
That's right. So she'll be here on the 25th and 27th. So if people want to have further questions, or they can tell other people who are not here, that we'll have the opportunity to talk to her directly. On a personal level, I want to thank you for taking the time to come tonight, and I want to also pass on a message that a lot of people who are not here tonight have given apologies. I'm not going to put their names, but a lot of people said they wouldn't be able to make it. Why? Because of the short notice. We didn't have a lot of time. We did this in less than a week, so not many people will be able to make it at such notice. I believe that this issue is very serious, and it might affect a lot of people in the community, so that's why we want to hear from Anne, not from anybody else. And that's how we've been doing this. We want to have the right information from the right people who can tell us their expert view. And I'll leave Anne to give you her findings of the report. Some of you might have read, some of you might have not. So she's going to go through it and talk to you about it. And I would like to thank you for coming tonight. Thank you.
Hello everyone, I'm Anna. I would like, before I'm starting my presentation, my apologies apologies. Usually I'm very direct, and probably I'm not the waffle person. If I'm upsetting anyone, please, my sincere apology, it's not my attempt. I came here today just to tell you about my results within the paper that was published, and that's what I want to focus on. I'm sure that you'll have plenty different questions as well, which I will try to answer, but at the same time I might tell you it is a very complex question, and I might tell you and explain you why. The first thing I want to definitely specify is that that study was done independent. No one paid me for it. I didn't work for anyone. So it's not the SACS work, it's not Grenfell inquiry work, it's not Public Health England, it is solely my work under my university that I work for. So everything what you find from here is actually kind of my own time that I got on Saturday to Dakar, got samples and then analysed. The questions I got, typical that I got in emails, is why was it so long? It's simply within the time that I had available for that and the time that it's taking to get that result. But I will tell you that through that presentation. And before I jump to my results, which probably you all want to hear about, I want to give you also explanation about them. So you've got a better understanding why I've done those, why I've chosen those, when there are obviously many more toxicants that are released in the fire. So first thing, hopefully it will work. Yes. So the first major issue with the combustion toxicology, the major issue with fire is it's very niche area, and you don't have many experts in that field. And the experts that are existing, they're mostly covering fire safety engineering. And the fire safety engineerings are looking like how long it will take fire to spread, how much time it will take to material to ignite, construction, and many others. But there are a few fire chemists that, for example, when you're mixing different chemicals, what would be the outcome? But in terms of the combustion toxicologists, there are only few of us. And I can tell you that two are very, very senior established, they retired. And within the academia, it's only us around the world doing it. If you've got institutions such as BRE or in Sweden, in Canada, in every single country, you've got a test house that's doing commercial testing. They've got capabilities to do fire toxicity, but it's only when they, for example, getting payment for that test, and the data is not always available because it's confidential, because it's for the manufacturer. So within the smoke, fire toxicity, there are statistical data that is collected by the government, and typically within all the data, we know that most of the people who die in fires, they're dying from inhalation. There is very minor number of people who are dying from burns or any other effect. And then everything what is typically happening within the fire research, it's mostly on fire safety engineering tools. So in other words, if material doesn't ignite, then we shouldn't look at the combustion toxicology because that shouldn't be a problem, because material shouldn't ignite. So all the studies are on kind of how much heat is generating, how much time it will take to ignite, and then fire toxicity is somehow ignored on that. And then looking from the last 20 years, and I'm sure you can see in your house, that the changing of the materials is really rapid. So going from the bricks, going from something probably very hard bed, you're going to very nice softy bed that it's very comfortable to sit, and also the number of the plastics you've got in a house is much bigger. And then the other thing that I'm just tiny touch it, is that within the UK regulations, we've got also flame retardancy. So flame retardants are typically added to inhibit heat release and inhibit ignition, but I'll add it. So overall, as I said, the first major problem, at least from my perspective, is fire toxicity is not regulated. So if you're going for any testing, you're testing for the time to ignition, heat spread, or reaction to the fire. But fire toxicity is not regulated. So if you go for any documentation, we're just telling you what you can put in a building. Obviously, we cannot regulate what you've got in a house, but we can regulate what you've got outside. The information you can get, and I'm sure you've heard about approved document B, which is very widely distributed, you will find only that paragraph on the fire toxicity, that people should be evacuated from the building in efficient and safety manner. That's it.
Sorry, can I just ask, can everybody see the...
Sorry, I can move that as well.
Can
Do
you,
you-
does
everyone
it need to
sees
be
that?
turned a bit? Can anybody see that?
You can see
Can
it.
you see the screen?
Yeah.
It doesn't need to be turned a little bit. Okay, sorry. Yeah.
Sorry, Anna, is it possible to have copies of?
Yeah, I'll give you copies.
That's-
Yeah, I'll give you copies.
Thank you, that's better.
You can circulate that. Yeah.
Thank you.
So that's the first problem. And second problem is its guidance. And guidance is that it can be used, but doesn't have to be followed. So you've got other options that you can follow it. But in terms of checking how much toxicants are generated in a fire, how bad they will be to a human environment, you will not find it. Just only recently, that you probably are aware, Judith Hackett released that the combustible materials are banned on any building higher than 18 meters. And just within the last month, there was consultation on the government website if fire toxicity should be included in the approved document, which is under the revision. And we still don't know results. Hopefully it will be considered, and we'll see where it's going. So a little bit about the fire. Typically, what you've got in a fire, you've got gas phase. And the gas phase, what I call it, is the smoke that you can see very highly kind of coming up. Then the second phase, we call it, is the condensed phase. And the condensed phase is everything what is sticky to the walls, to the cold spots. That's what we call. And then finally, it's whatever is left under the fire as a residue. So when we're looking at the fire, most of the studies are done on an acute toxicity, which means immediate effect or very short effect from the gas phase. And again, we're coming back to combustion toxicology. There is absolutely very little done on the contamination within the soil or within the condensed phase or the residue phase. You might have some published papers on the waste fires, what is left for environment, but it's still very, very limited, simply because there is not enough experts on that one. So, how we can interpret fire toxicity? First, we started looking on two major factors that will affect how bad it will be to a human. First is how big fire is, if it's small fire, medium fire or big fire. And depending on that type of the fire, we know that there will be different concentrations and different toxicants created under that regime. And when I'm saying small, big, medium fire, it is typically how much oxygen is available to support that flame. And then chemical composition, so what material is burning. Because if you, for example, got a cable, and I'm sorry, I'm going a little bit on chemistry, so if I'm going too much, tell me about, move on. So if you've got PVC cable, PVC or PVC window, I'm sure you've heard that name, it contains chlorine. So it will be different toxicant that, for example, you've got polyurethane foam. Polyurethane foam is something that's soft, you're sitting in, and it's something what it was also polyisocyanuric foam, which is also what was on the tower. But generally, they will contain nitrogen, and they will release different toxicants that, for example, you've got in a cable or if you've got in a house. So we're strongly looking typical content of the house, and we know more or less everyone will have television, everyone will have sofa and mattress, everyone will have something like a wooden structured table or cardboard. So we know more or less what could be released from that. Then within the insulation materials, I'll show you some examples later what might be released. And then fire retardants is another one, because according to UK regulation, most of the materials or content that is in a house has to be fire retardant. So starting kind of from typical fire, that's at UConn we've got a lot of fire safety engineering courses which we're doing fire investigation. So we've got containers that we're setting for students, we're setting them to the fire and then telling students to identify what has happened. And at the same time we're doing some evaluations for the fire toxicity. So within the assessment of the combustion toxicology, we're looking at the flaming. Because for the smoldering is pretty nasty, because when you've got like a cigarette smoldering, it will be quite full combustion of organics, which are sticky, which will be pretty bad. But in order to pose a threat to a human, we're typically looking at the sealed room that would have to be lab concentrations very, very high, or it would have to be somehow a particulate stick to the walls of any other environment. So within the flaming, we've got small fire, like that, which is well ventilated, we call it. You've got plenty of oxygen that will support to spread that fire to the other objects. And within the fire toxicity, you've got typically low concentrations of toxicants and low hazard to people and kind of pretty short time limits when people are able to escape. But if you want to tell me how much time, I would say it depends what it's burning, because each material will have different characteristics and it will take different time. Then spread of the fire, again depending what you've got. The fire smoke plume will go from the ceiling, going to the lower levels, to the floor, and then within the fire spread, you've got increase of the number of toxicants within the time. So it's intensifying. And then underventilated. So from our data, that underventilated fire is the most dangerous to a human because it's the biggest fire, it's got the highest concentrations of those toxicants that are generated, and also the most toxic toxicants are generated during that fire scenario. So I kept you a little bit on chemistry. PU is polyurethane foam, or PIR is polyisocyanated foam. They contain nitrogen. So typical fire effluents that are released in a fire, there will be hydrogen cyanide, probably you've heard, or nitrogen oxides from evolution, if you heard, or kind of ammonia or a few other ones. Within the smoldering or very early fire, if you've got nitrogen-containing material, there will be also isocyanates, which I'm going to come back later. Then within the materials containing chlorine, bromine, you will have irritants, very strong irritants giving you warning in a fire. They will irritate eyes, mouth, throat very strongly. And typical gases will be hydrochloric acid, hydrobromic acid, or hydrofluoric gases. Every single fire, when it's flaming, will generate water and will generate also soot. And soot is kind of part of particulates. And that is kind of related to every single fire. So within the acute toxicants, just to kind of bring that a little bit, we've got two major acute toxicants. We've got three classes of acute toxicants, which are smoke, and smoke by itself, it's particulate, that typically will have an effect on human with the irritant effect. Then you've got irritants, which I mentioned, hydrogen chloride, hydrogen bromide, strong corrosive gases. But then the most important is carbon monoxide and hydrogen cyanide. And carbon monoxide, similarly to hydrogen cyanide, will remove oxygen from the red cell. So it's asphyxiant. However, hydrogen cyanide is got much more rapid potent than carbon monoxide. So typically we're saying that hydrogen cyanide, it is more toxic, it will lead quicker to loss of consciousness, while carbon monoxide will be leading to the death. The other thing I want to bring up with hydrogen cyanide, within the post-mortem is morally and kind of typically based on the measurements of carbon monoxide in the blood, which is carboxyl hemoglobin. That it's done not to say that carbon monoxide is contributing to the death, but carbon monoxide is stable in the blood, and therefore can be identified if the person was inhaling the fire, so was alive during the fire or not. Hydrogen cyanide is weak acid and is degrading very quickly in the blood. Therefore, it's very hard to identify what is the level of that. And that analysis typically needs to be done very quickly if you want to identify hydrogen cyanide in the blood. In terms of the cause of death, if there is carbon monoxide, that can be correlated to carboxyl hemoglobin, and we typically got levels that if it's below 50% of carboxyl hemoglobin in the blood, we assuming that person died from something else than carbon monoxide. If it's higher than 50%, it's more likely that it was caused by carbon monoxide. So there is indication of kind of cause of death. So going a bit on the insulation materials, kind of the most common one, insulation materials that are used around the world, you've got polyurethane foam, which contains nitrogen, polyisocyanated foam, which is PIR, I will call it shortly, which contains nitrogen, phenolic foam, which contains oxygen and nitrogen, and expanded polystyrene, the foam, and then stone wool. Starting from the easiest, stone wool, it's in other words, it's made from the rock, so it will not burn. If you've got polyurethane foam, it contains nitrogen, and then PIR, what we call it, is a special form of PUR because it's got a little bit more nitrogen than PUR. Phenolic foam, it mostly contains oxygen and tiny amount of nitrogen. So if you look at the nitrogen content, you will have PIR, PUR, and then phenolic foam. All those compounds, those ones, I would call they're combustible, and also all of those will contain also fire retardants in them. So fire retardant will be not in kind of typically on the other materials, but you can find in the foam specific fire retardants too. If we look for the toxicity, something hard, but that one is PIR, so it's polyisocyanated foam. That one is polyurethane foam, so a little bit less nitrogen. Phenolic foam, even less amount of nitrogen. Expanded polystyrene doesn't contain nitrogen. Stone wool and glass wool, they are made from the rock, so they do not burn. Within our estimate for the fire toxicity, we've got a few equations which I'm not going to show you, but we can estimate when it will become dangerous to a human. So just simply tell you, we've got something what is called fractional effective dose. Under that fractional effective dose, we are assuming that 50% of that population under 30 minutes will, with that exposure, will lead to the death. Remember that all our estimates are done on animals testing, because obviously we cannot take, and even now, within the Europe, animals testing is forbidden. We are based on analytical measurements, so analytical instruments. So those ones are typical fire scenario I was saying. Oxidative pyrolysis is just smoldering. Then you've got small flaming, which is well ventilated. Small underventilated is the big fire. That one is when the fire is starting spreading out of the room that it started. So it's moving to the other environment. And what you've got PIR, within the contribution, you've got first FED higher than 1, which means it will pose a threat to a human. And then you can look at the contribution of different toxicants, bringing overall to FED, and you will find that within the lethality, hydrogen cyanide will play a very big role when you're comparing this to carbon monoxide, for example. For phenolic foam, because you've got very tiny amount of nitrogen, you will have mostly CO, because oxygen is there. And then expanded polystyrene, it is just kind of very nice, a ring, close ring, which is part of particulate. You will have plenty of smoke and particulates from it, but not much kind of in terms of the overall toxicity. And the stone wool and glass wool, obviously they do not burn or ignite. So chronic toxicity, long-term toxicity. That's something what I try to do in a paper, at least kind of preliminary studies. So first thing, there are particulates, and something what I will call PAHs, which are polycyclic aromatic hydrocarbons. Then something with very long name, I will call it dioxins and furans, organophosphates and metals. So, particulates, they are part of PAHs, and I will show you on the structure how it looks. Dioxins and furans, they are existing when you've got a chlorine or bromine in the compound. So dioxins are precursors either of fire retardants that were present, or something that was halogenated like PVC cable or PVC window. Organophosphates, I focus here on organophosphates because they are fire retardants that are commonly used, halogenated organophosphates are used in all those insulation materials, the combustible insulation materials that I pointed you out. And metals, obviously, metals can be heavy metals, typically also used for kind of parts of them, for example, cables. Very difficult, but this one with, double ring, it's supposed to be kind of, it is a close structure, it's called benzene. Benzene on its own, you can find it as in air pollution, but on its own it's classified as carcinogenic. And it's carcinogenic because if you've got that structure inhaled, for body it will be very difficult to break it because it's a very nice structure that cannot be really removed. And then those kind of rings are combining in a fire together, which are creating polycyclic aromatic hydrocarbons, those ones I just mentioned. Then, if they're combining together, they're creating a soot, which got a lovely kind of structure. And the trouble with that is that you've got water in a fire, it will absorb also all the other irritants, which are sticky, to that one. So they will also potentially have an effect if they inhaled. So what we're doing then is that depending on those structures, how they combine together, they are classified by World Organization based on the epidemiological effect. If they are carcinogenic to a human, potentially carcinogenic or possible carcinogenic. When we're talking about possible or potentially carcinogenic, it's not enough evidence on a human, there is enough evidence on animals. So for the soil studies, we've collected only those that are classified under 1 to A to B, which are carcinogenic, potentially carcinogenic, or possibly carcinogenic. The bad thing about the fire, that each fire will produce soot, and that soot will have those PAHs. The question is, how much of them, and what is the concentration? Which I'll just come back a bit later on that one. So, skip that one. Fire retardants, the other thing that we found is that if you've got fire retardant, particularly halogenated, chlorine or bromine, we found that in a fire, it will increase fire toxicity. And what you can see, again, FED, which is kind of equal 1. So if you don't have fire retardant, you've got pretty low overall toxicity. But if you add halogenated fire retardant, you will see that HCN is dramatically increased because of the action of fire or halogenated fire retardant, which contains bromine or chlorine. So within our studies, for some of the halogenated fire retardants, we would say, wait a minute, you should include fire toxicity. Because if you're using that specific fire retardant, you've got a problem from the fire toxicity perspective. Some of the fire retardants are fantastic because they're delaying time to ignition, they're reducing heat spread release for the given standard, but at the same time they can release really bad cocktail of toxicants. Right, getting back to the paper. So what I've done is I've collected soil samples from those locations that you can have it within up to 300 meters, and then I've taken a reference sample from very far away just to compare how different that soil with the contamination is to those points that I've taken here. Typically what we call it is the reference, and on those stages we've taken 2 different types. One is something what we call reference used for contamination, which is called catering soil, which is kind of bought from the typical website, and then taken from there. For some of the measurements, we know that they're done on regular basis in Hyde Park, so we can typically compare how bad it is, or how good it is, or how clean it is. We've taken sample also close to the motorway, because on motorway you will have air pollution. So nitrogen oxides, benzenes, those are typically one that you should find. At the same time, when we were walking around, we found also debris, burned debris from the tower that fallen off. And we also analyzed them. What I want to say is that typical question, which obviously is very important, how toxic it is when I'm touching it. And my truth answer is, it's definitely not good to touch it, but how toxic it is, even I can't tell you. Because there is no measurements done, there is no epidemiological studies, no one has done it that before. No one even analyzed the fire debris. Post-contamination, almost no existing measurements from the fire effluents. So it's very hard kind of to tell, but we know that that burned debris will contain carcinogens, tetrahedral mutagens. The next question is, if we want to evaluate what would be the effect, we need to take 3 additional questions. 1, how long you're touching it, then how often you're touching it, and what is the surface that you're exposed to. I can take question later. Do you want to, yeah, just.
And it's fire debris, is that just what falls outside the building, is it not what falls inside the building?
No, not, it's only outside of the building. Within the paper, I've tested only what is outside. So I've taken soil outside of the tower, and the burnt fire debris lying around, or found it outside of the tower within a distance up to 160 meters. So that's kind of summarizing you. So sample location, you can see that I tried to keep increasing the distance from 27 meters, which is just in front of the tower, which you can see from the locations, to the furthest away with that park far, far away. And the materials I've taken were fire debris that fallen off on the ground, that I could easily find, and then chaff from balconies. which kind of was founded on people's balconies within that distance. And the last studies I've done it was just to take a dust sample from someone's flat that indicated yellow color and changing color on her window blinds after a very long time. And it gave me some concern, so I've just analysed that. I can show you where to download my paper as well, so you will have it. And you can download for free, everyone can get it and download the final version. So, toxicants. If we're talking about PAHs, we combined all those PAHs, which are 17 of them, or 6 of them which are presented here, and then look at the concentration to compare to the concentration that is given in a Hyde Park or Kettering soil, which is just a reference soil that it doesn't have anything, it's just pure soil for our benchmark, for our methodology. Each of the soil that we've tested was done 5 times. Why? Because if you're taking different spots in soil, they will all differ. And we have to have a rigid, thorough studies done as an average. So for each of that measurements, it took 5 times, and then from the beginning, from taking the soil to sample prep to sample analysis. And what we found is that you will have higher concentrations within the close vicinity of the tower. So that's for PAHs. Next one, we've taken for benzene, and that's kind of reflecting your PAHs as well, that you've got higher contamination, and if you go for very close to motorway, you will have higher concentration of that benzene, but not as high as within the closer distance to the tower. Glass fibers. One thing most of you are concerned about asbestos. We didn't find asbestos, and we didn't find that asbestos in the soil or in the char. We found it synthetic vitreous fibers, but synthetic vitreous fibers, those ones that we identified, they are much thicker and much longer than asbestos. So typically, they will have not any characteristics to lead to mesothelioma. They're much thicker and much longer. They don't have anywhere close properties to asbestos. Why I've taken them? I think I've taken them for 2 reasons. One, to relate that soil contamination that is coming from the tower. And those synthetic vitreous, I know that were used in some of insulation materials on a cladding, on a facade. So I could definitely tell you that glass fiber is coming from the tower. That soil contamination that I found in those fibers is coming from the tower. It's not from Victorian fires. It's not from the recladding or building the school or whatever else.
Sorry to interrupt there. There's absolutely no other source of that except that cladding. Is that what you're saying? Nothing
Yes.
else.
Correct. So what we've taken, and it's in the paper, additionally to the microscopy, when we compare thickness and the length of that fiber, we've taken also elemental composition, which tells you how it's built, what it contains. And within the elemental composition and reference material that we bought it on the market from the commercial sources, exactly the same material that is given in the Grenfell Tower report, it's giving you the same characteristic. So we know that the fibers we found, they are coming from phenolic form, and they're coming from the polyisocyanated form. We found 2 different types. The fragments you can see here, which also I wanted to point on the picture, what do they remind you? These pieces,
Cancer.
these pieces are burnt insulation material. If you take a foam and you burn it and you look at the microscope, those tiny pieces, if you put them together and you look at the foam from the furniture or you take the foam from the cladding, this is typically related to that one. It's not the soot. Soot would be kind of tiny, like a needle, particulate. That one, which I found it, most of the things I found it, they are burned combustible materials, not soot. I had actually very big problem to find soot. So that's another reason, just to say, it's not from anything else, it's actually from the tower. So coming back and kind of looking forward for your questions, I would say the studies I've done, what I want to also say is that they are preliminary. I've taken only 3 or 4 major fire effluents that I would expect that they should be there. You've got longer list, which I would say that will be or should be addressed under further studies from government, and I'll give it to Zach to talk about it. At the same time, I would say within my time constraints, and also obviously you're impatient, you want to know what is going on, especially after the press in October. I just had to stop at some point and just say, I'm not going to analyse further toxicants. I just want to come and tell you, okay? So within that, I would say fire tox. If we've got regulation, if we know what is going to be released, we can protect you, we can protect environment, we can also protect emergency responders, because they were also exposed to that. And on that note, I'll just thank you for your attention. I hope.
Okay, I'm going to take questions in batches of 3. If we can try and actually make sure we get a diverse range of people speaking, so that I'm not going to take the same person twice unless no one else has their hand up. Okay, so I'll take Tariq, Yusuf and Joe. Oh, sorry, Nabil and then Joe. Yeah?
My question is this. I came across with this and I kind of touched it a couple of times. It's what you had on your test.
When is that, Jerry?
August 18th last year. I sent it to everyone in the group. And
That-
ever since I've been having problem with my skin and I'm bleeding a lot from my throat when I cough.
This on your picture is part
Yeah.
of the
There's
combustible and char insulation
Because I
material.
was inside when there was breach of security and I did inform GU, Humanity for Grenfell, that the doors were open at Grenfell.
This is the material I found.
Yeah.
This is the material what I call char.
And I think it was too late for you to tell me don't touch it. Sorry.
Okay.
My
Thanks.
question is, how is the council or the local authority dealing with this issue? How is the council dealing with it? I mean, did they cover anything? Are they involved, or are they completely hushing it down, ignoring it? Like what happened on 9/11, we know that there was a lot of people affected by the dust and all that, and many have died from fire departments. So whether that is in a way, it would affect a lot of people in the community where the council is not involved and trying to brush it as they always do. So
Okay, and let me just take Nabil's question, and then Emma may want to come back on that. Nabil?
Professor, I'd like to ask you, did you say that the higher you were within the tower, you were subject to more intoxication or poisoning, whatever you want to call it?
I know where you're going. That question is under Grenfell inquiry and it's going to be answered. It will be answered.
Then my next question would have been, when you did a report or a survey where you found the materials, did you do it on all 8 points, like north, east, north, west, south, and all that, and spread it out? Because depending on the wind direction
Yes.
of the day, you would have determined how far and where
Yes.
it went.
What I've taken is pictures that were done from helicopter that night and up to 3 days later, and see where the fire plume is going. And then also the locations where I can actually get the soil that is, you know, not covered by the trees, or kind of that you've got open layout of that soil. And within the locations, I would say you've got them more rather in one direction, which would be more smoke direction, I would say, from the pictures that I've taken. But in terms of different points and different locations, I do hope it will be picked up on the further detailed evaluation.
Joe, can you got a quick?
I mean, you spoke about one unique.
Sorry,
item.
can you speak louder,
Sorry,
please,
yeah,
Joe?
you spoke about one unique item that's present in the area. Are there any other sort of unique fingerprint type items that we can look for, that we can explicitly say
I think that's also included under the SAC, that it's given typical list of the fire effluents that are released from the fire, and you will find them in a fire. So for example, fire retardants, you will not find them in the soil, you will not find them in the air, you will not find them from air pollution, because they're specifically released under the fire.
My next question is that the samples that you took, are any of those left? So for example, your work will be replicated, so to retest, to ensure its accuracy and robustness.
I would say I've got some, but for some analysis, like for the chart, you need typically very high quantity of that because it's very light. You need to have quite high, considerable amount to get detection limit on analytical instrumentation. So my question would be, what do you want to repeat? What do you try to find out?
No, I mean, literally, my understanding of these sorts of scientific experiments is that if you cannot replicate the result, if you cannot replicate the test and replicate the results, then those results do not stand. I have a feeling that we'll just be told that, well, look, we've tried testing and nothing's come up, so what are you going to do? We assume nothing's here.
No, you can do it different ways. You've got different ways to do it. One would be, I would say, for me, based that I gave you preliminary studies showing that there is some contamination of fire effluents in a soil, I would say go take the sample. Once you've got validated methodology and analytical methods, you can validate your results by different comparisons, taking the other samples rather than coming back to all the samples.
And the final question from this part will be, in terms of volume of soil, how much would you need to test for any of these items?
That would very strongly depend on the list of toxicants you want to look for, because
we're looking for the unique markers, whichever one would be most likely to find or would be the most harmful. How much soil do we need? Because I'm thinking that there are going to be samples taken as part of planning applications around here which are still in storage some. And I want to know whether we could pull one of those out of whatever filing cabinet it's in, and there would be enough soil there to test for a particular item that we, so we can categorically say on this date it wasn't here, and then on this date it was.
I wish it would be easy answer, but it's going to be a little bit more difficult, because if you're collecting soil in every single point, depending on the depth, would be different, because though some of the toxicants will travel with the rain, for example, and will be bounded to water, which is from rain. Some of toxicants will stick to the soil, so they will stay with the soil. And those which are traveling, you have to look at different depth. For those which are staying on the surface, you need to have a broader one. And then if you're taking broader scope, the soil will be different in different places. So you have to take soil property as well into account. And then the concentrations you want to detect, because you have sensitivity of analytical instrumentation that is also limited. And then the final one is that if you're getting concentration of one specific chemical, you have to repeat those analyses in order to get variations from which point to that point it will differ within that region that you collected. So, sorry, I know you want to know answer very quickly. Similarly, if you've got stored char...
I'd rather a thorough answer, exactly. I'd rather a thorough one. We had quick answers, I was told last night from the Chief Scientific Advisor.
The other one, I would say, with the char, it is the same problem, because if you've got char material, you have to look how much it's burned. Because some of the cladding material might burn after smoldering only, and you will have only 5 millimeters or 1 centimeter burned, and then absolutely unburned. Some of the burned material will be totally burned. And some of the char will be kind of just a dust. Then the question is what you will call reference sample. So what we've done for that studies is that we've taken 16 pieces, combined them together, because some of the pieces we found that they're coming from PIR, some pieces are coming from phenolic foam. So, and if you want to know that, you have to test it and do additional analysis, which you're losing a sample. So it's a little bit harder, but then within some scientific understanding you can get there. There will be some compromises, but it can provide you some information.
Okay, I've got another, after 4 hands.
Do you want to answer this gentleman?
Quickly.
Oh, yes. So your concern was that there was going to be a cover-up, I think. Yeah. So me and my colleague at the back there Choucair, we are on the council, and I'm also the MP if you don't know me. This is exactly our concern, which is exactly why I'm so happy that Anna is here, because the more we understand about what has happened and what there is, and the better informed we are to keep on asking those questions and to ask the real questions rather than getting a snap answer. We want a thorough answer like we just had. So
Well,
the better
glad to
informed we
hear.
are, we have to keep on asking awkward questions, because they would love to shut this down. That's my fear. Government and council would love to shut it down, but we won't let them.
I'm glad to hear, and I hope the council will run their own independent test too.
This is
It's
Okay,
good
if
to
we
have.
come back to that issue
Yeah.
afterwards, just so, because people need to, and I'm mindful of the time.
Thank you.
Okay, 1, 2, 3, 4. Okay?
Thank you. Yeah, Lucy Gaddens, I'm here from Northampton Law Centre. My question really is in relation to, there are plots just below Grenfell Tower between the walkways where people have been growing things, and I'm aware of one particular person who has been eating things that they have been growing in their plots, and their concerns for the toxicity of anything that they might have grown and might have eaten last summer, the summer of the fire, and then, for the two last summers, and the difference, and whether they're going to be able to grow fruit and vegetables in their plot almost immediately below the tower, and how dangerous that is, which is, I don't think anything that anybody does.
One thing that I have to answer is that I'm a fire chemist, and in terms of proper soil contamination and food, I would say Food Standard Agency should know an answer on that one. But in terms of the contamination in the vegetables, what is my understanding as a laik, really, because it's not my expertise, I would say that you need to, in order to get to the vegetable contamination, it needs to go through the soil, which will be pretty long time, when it's growing up. So at least kind of, I don't know, a few months to 15 months or 20 months, I don't know, depending on the vegetable. And the possible contamination would be from the stuff that is coming from air on it. But at the same time, I would say to get in it, probably you can remove it by very thorough cleaning and boiling it. That's what I would do. But in terms of how badly it's contaminated, I would say it should be tested and checked.
Okay.
But it's not my expertise, so I can't give you a proper answer on that one.
My name is Elizabeth, I'm one of the local residents, and I just wanted to say that a lot of people were exposed to the chemicals on the night who were not actually in the tower. Then for the following day as well, then there was a plume which I'm not quite sure which direction it took, but then we asked for the air to be monitored, and we didn't hear anything for well over a week. And then after the first rains, there was some monitoring, and they told us that the air quite far away from the tower was clean. So there's a lot of missed opportunities. We don't exactly know what the toxicity was on the day. We don't know what the toxicity was on the night. We don't know what the plume had and what we breathed in and what the trail was. So, post-fire and 22 months later, and obviously we don't know what's inside the tower, and the tower wasn't sealed for weeks. So that was blowing around in the wind. So now you can't give us those answers. But what I want to ask you, because you're the person who knows more than most of us in here, is there any other way, apart from the soil that you're testing, but perhaps tree barks and other methods that can give us a reading of what happened closer to the time of the fire?
Difficult one. Simply on the fact that if you go for the chronic toxicants, many of them are unstable in the soil, and they reacting and they degrading, and you will not find them. For example, hydrogen cyanide, typically on its own, it's gone. Benzene, it's very unstable too, and you've got many of them that, there is no point to even try to measure them, because it's going to be gone within a very short time in the soil. Similarly, isocyanates, they will be gone.
It's beyond me that they didn't test it immediately. It's beyond me that they didn't close the schools on the same day and allow kids to go to school in the vicinity. It's beyond me. that this information is not out. I do not understand how it's possible.
I can't answer that.
We're all with you on that one, isn't it?
I think with recommendation I would do is to initiate health screening for fire effluents to kind of identify and check and make sure.
So we need to know specifically what these components are that can still trace in our blood and in our body. Because a lot of us now have gone back to our GPs for this screening. A lot of us have been ill. A lot of us have been ill.
What I'm worried, and I have to say, and I wish I would be able, I can tell you from publications from US or from the other countries, what are those specific elements or chemicals are that they stable in the blood. Do you know is the problem? There are not many people doing that work around the world, and there are no analytical methods that are validated to do that. So in UK, if I would say, can we check how much you've got organophosphorus from retardant in the blood, you wouldn't find probably anyone who can do it. We've got methodology because we validated from the fire, but I don't think anyone else is out there. Probably there might be labs in US doing it, but I do not know if you've got anyone who's doing combustion